Okay, let's try this. All right, class.
Yes.
All right, so yes, you're the manager.
No.
No? Okay.
I'm a short stuff.
Oh, you're the stress staff?
Short stuff.
You're the short stuff.
I am
One more
short.
time. One more time.
I'm a bench warmer. I'm just saying. Bench warmer.
Wow, okay. So, you do play on the team though, right?
Yes.
Okay, that's all I was asking. But
Oh.
I couldn't hear what you said the first time.
I said shortstop.
Shortstop, thank you. Yes.
Shortstop.
That is a position in softball.
It is.
Okay. All right. 5.6 half-angle identities. 5.6 half-angle identities. So please, please, please make sure unit circle and reference sheets out. We're going to need them all. Okay? We will need them all. Now, before we get started, please look at your reference sheet and find where it says half-angle identity. Find where it says half-angle identity. It's to the right of double angle. There we go. So, there we go. So you guys can see all of those there. Now, okay, so, okay, blah, 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 blah. There we go. Now, if you notice here, the half angles identities are up here. And they kind of go along with what we had before, but this time tangent is the one that has three difference. See? Gotta mess up my video and everything. What? Anyway, whiskey. All right, there's three different tangents. Remember when we're doing this, the cosines of the double angle, and we always use the one that was easiest for us. Okay? Same thing goes here. So if you notice, after we do example 1, example 2 is a tangent problem, and that will help you to figure out which one of the tangents are going to be easier. Yes? Does that make sense?
Yes.
Okay, good. This example right here says find the exact value of cosine 15 degrees using half angle. So it's going to be the cosine of something over 2. It's not 15. What's 15 divided by 2?
30.
Nope, try again.
7.5.
7.5. So I don't want that, do I? So something divided by 2 gives me 15.
Oh, 30.
30. There we go. I know. Let me hear what you said the first time. You know when you're like trying to like whisper the answers to people and they're still not listening? You don't do that? I do that all the time. Yeah, okay. I do that all the time, but I was giving the wrong answer. Okay. So it's going to be 30 divided by 2. It's going to give me 15, right?
Whoa.
So in my formula, right here, the A value here is now going to be 30, right? Say yes?
Yes.
Okay, the A value is going to be 30. So when I plug it into one of my formulas, I'm going to replace the A with 30. Very good. And so in this one here, it's asking for the cosine. So it's asking for a cosine out of it. So it's going to give me cosine of 30 over 2 is equal to plus or minus the square root of 1 plus cosine of 30 over 2.
How do you know how to use that one? Oh, this is all one.
This one over here says what? What are we looking for? We're looking for, that's why.
Wait. Oh, but you just said 2.
Yeah, look at the formula. This formula has a cosine, doesn't it? But this one over here also has a cosine. It's just whichever formula I'm using. So you have to be careful with which one you're doing. Does that make sense? Now, 15 degrees is in what quadrant?
1.
It's in quadrant 1, right? 15 degrees is in quadrant 1. So what do we know about cosine that's in quadrant 1? It's positive, so I can get rid of my plus and minus, can't I? Because I know it's going to be a positive. So it's now going to look like this. It's going to be a positive. Now let's go through and start replacing some numbers. We're going to replace numbers. Cosine of 30. Do I know what the cosine of 30 is?
15. Wait.
Yeah.
Wait.
Rad 3 over 2.
Rad 3 over 2. So now my unit circle comes into play. Cosine 30, that's the x value at 30. It's going to be give me rad 3 over 2. But if you notice, I didn't deal with the 1 yet. Why did I not put down the 1?
Oh, you wanted the 2.
What am I going to do?
2 over rad 3? Or no, 2 over 2?
2 over 2. Yes, I did hear you, but someone was just a lot louder. So it's going to be 2 over 2 plus my rad 3 over 2.
Why is it plus? The other one was like, didn't you multiply it last time?
Okay, what's my formula say?
Dude, I'm sorry.
1 plus cosine, right?
So the 1 right there is.
The 2 over 2
Oh,
plus my cosine 30, right? And all that's going to be over 2. All this is over 2.
He's all got 2s.
Why are these 2's different?
On the top of the fraction, up here in the numerator, do they have common denominators now? Yes. So I'm going to do the Pac-Man thing. So it's going to go out the right side, come back in the left. So now inside my radical, I'm going to have 2 plus rad 3 all over 2. But now the 2 on the bottom, I got fraction over fraction anyway, right? I'm going to write, isn't that a whole 2? Yeah. So I'm going to write that as 2 over 1. And that's going to help me out later. Is that still a whole 2? Yeah, it's still 2, isn't it? Even though it's 2 divided by 1? Since I have a fraction over fraction, I got to clean that up. How do I clean up a fraction over fraction? Very good. Multiply by the reciprocal. So watch how I do this. So still inside the radical. So it's going to be 2 plus rad 3 over 2. Let me extend this. Now times the reciprocal, which is 1/2. So like I said, this does take a bunch of algebra. So, you know, it's one of those things. But 1 times anything, I get the same thing, right? I get the same thing, nothing changes. But now on the bottom, the 2 times 2 is going to give me, there we go, it's going to give me 4. So it's going to give me 2 plus rad 3 all over 4. Now, here comes that algebra trick. It's a fraction inside a radical. Can I separate those? Yes, I can. I can separate those, can I? So since the fraction is inside, I can separate the numerator and then the denominator. So the numerator is going to look like this. 2 plus rad 3, right? The denominator is going to be rad 4.
Why can't you just leave it though? Why can't you just leave it?
Because technically it's this right here. I still have a radical in the denominator.
Oh, okay.
And then you multiply by rad 4, right?
No. What's square root of 4?
2.
So it cleans itself up, doesn't it? So the rad 4 is just 2. So on the top, I'm going to end up with the square root of 2 plus rad 3 all over 2. So yes, this is a progression. It is algebra step by step. So my last answer is right there. Now,
Are those 2 2's or is that a Z?
say what?
Z.
Hold on, say it again. Someone asked me something.
You asked if the bottom number was a Z instead
the 2. So if it was a z, that's a z. So it's not. So just because I already know that there is going to be an issue on misunderstanding there, I crossed my z's. Okay. Anyway, so now also, let's pretend like I want to check my answer. Would there be a way of checking my answer?
Check it back in the
No. I heard something else over here.
The unit circle.
No, no.
Oh.
Say what?
Plug it in.
Plug it in.
Plug it into where?
15.
Calculator. So this is going to be key to some of y'all's success.
That's a big calculator. That boy's a genius.
Okay. What mode am I in right now? Okay, because it gives you 15 degrees, right? So we start with cosine of 15 degrees. Hit enter.
Can't you just put equals and then do that and say
You could. You could do that. So I'm going to, because sometimes it's not as easy. Let's say, for instance, you have a multiple choice test and you're trying to check your answers. Do you think you would have to check all 4 like that, though? I wouldn't do that. But let's look at what my answer gives me. So I have control divide. So I set up my fraction first. And now I do my radical. And it was 2 plus rad 3, right?
Yep.
And all this is over 2. Yeah? Hit enter. Are they the same thing? Yeah. So my calculator, I have verified that my work is correct in the calculator. I verified that these are correct. So now from here, we're going to take a couple minutes and then work on some problems from the homework. And then we'll come back and do example 2. All right, let's try. Class?
Yes.
Okay, good, good. That was a good solid one. That really was. I'm feeling pretty good after that. So now this next one right here says it's going to be find the exact value tangent 22.5 using half angles. So that's going to be a tangent of something over 2. So someone else actually mentioned it about just convert it to a fraction. Someone else mentioned about convert it to fraction. And so that's one way of actually figuring out your A value you're supposed to get here. So I'm going to take 22.5 on my handy dandy calculator, hit menu, hit number, and hit convert to fraction.
Repeat. Go to menu.
Menu. Number.
Wait. Is something supposed to pop up? Or?
No. Okay, where are you at? Oh, you gotta get a scratch pad first. Menu, number, convert to fraction,
Or is number 2?
and hit enter.
Approximate the fraction.
Approximate to fraction.
And
So that 22.5 just turned into 45 over 2, didn't it? Yeah, so you had to have the 45 over 2 in there first. I'm sorry, the 22.5 over in there first.
in the parentheses.
Yeah, sure.
Oh, that's why.
Yes?
Number is approximate fraction. Oh, it's 45 over 2.
Yep, 45.
Yeah.
So this is 45. So my A value is going to be 45. Yeah? A value is going to be 45. Now, I'm going to help you out on this. Tangent has 3 different formulas. 3 different formulas. From that previous problem, what made the whole thing kind of messy?
Sine of a cosine.
How about that square root? Didn't that square root mess it up? It made it kind of messy, didn't it?
What are these?
Example 1.
Oh, yeah.
So what do I want to avoid?
The square root.
So this one right here, I want to try and avoid that. But I'm not saying get rid of it. I'm just trying to avoid this. Because that's not one I like. Sometimes you might have to do that. But, okay, try to avoid that one. That's the harder of the two. Now, the one on this one here, this one right here, is a little bit more different. A little bit different. Just depends on the numbers that we're dealing with. So, do me a favor. Take the finger, the magic finger, and put it on 30.
On what?
30. Yes, take it out your nose, put it on 30. Okay? On 30. So now let's look at some values that we have here. Look at some values that we have. So, some of the values, look at the x value at 30. What is the x value at 30? So the cosine at 30 is rad 3 over 2. Do I want to intentionally put a radical in the denominator? No, because that tells me I'm going to have to rationalize anyway. Now let's look at the next one over here. What is sine, since your finger's still sitting at 30, right? What's sine at 30? 1/2. Would I use this one here? I would use this one here because there's no radical, so I'm knowing I don't have to rationalize. I'm not making more work for myself by putting a radical in the denominator. So it just depends on what I'm doing. Okay? Depends on what I'm doing. So it really doesn't matter. And I want to try to avoid this one if I do have a radical, because to rationalize this piece right here, I would have to multiply by a conjugate. Do you guys remember the conjugate? Remember, the conjugate would be like 1 plus radical 2, and the conjugate of that would be 1 minus radical 2. I would have to do that, and I would have to fail that, combine like terms. It's still possible. We've done all this. Just don't make more work for yourself. Try not to make more work for yourself. That's all I'm saying. So that one's try to stay away from that if you can, but sometimes you can't. So you just deal with it. So that's where I want to try to get to. So now let's go back to my tangent that I'm using. It's 45 over 2. So now that my finger is moving from 30 over to 45, so this is 1, was it minus or plus? Minus cosine of 45 over sine of 45, right? Yes, hopefully. Okay. Now that we have that there, I have my sine and cosine I need to plug in. So at 45, 1, come on, minus cosine at 45. Rad 2 over 2. Divided by rad 2 over 2.
Let's just separate them and then make it into a 1 and then, or no. Like have rad 2 over 2 over rad 2 over 2 to make it 1 and then have the 1 over rad 2 over 2. Yeah.
That would work. Yeah. Good job. That's a good one. That's smart. Okay, let's do it this way. So, because otherwise it's 4 steps from here. So he's saying leave it like this, but from right here, I could separate it because they're over one denominator here. So he's saying that I could have 1 divided by rad 2 over 2 minus, because I'm separating, because right now from a common denominator, we're separating the two denominators. Rad 2 over 2 divided by rad 2 over 2. So this right fraction, I have the same thing on top and bottom. So what's that going to give me?
1.
Very good. That just all cancels out and gives me 1. But I got a fraction over here on the left side, don't I? So I would take 1 and multiply it by the reciprocal of the bottom, right?
Right.
So it's going to turn into 1 times 2 over rad 2. And I still minus the 1, which this canceled out to become the 1, right? So if I'm looking at it still, so this just gives me 2 over rad 2 minus 1, right? It's almost there. I can't have that there, can I? What do I have to do? I have to rationalize that anyway, right? But since I've separated these, they're two separate fractions now. So I only have to rationalize that first one. So it's going to be 2 over rad 2 times rad 2 over rad 2 minus 1. All right, we're going to do the Pac-Man thing. Where we no. Waka, 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 waka. Yeah, and head back over this side, right? So it just went through on that side and it's come back over here.
Wait, so had we not done had we done it the other way with the 4 extra steps, would that pretty much look the same like the first problem? Well, or different because it was tangent?
It's going to be the same. I'll show you when I did it on the other one because I did it for my other class.
Okay.
I'll show you the steps if you want to look at it. But this one actually does look a little bit easier.
That's it?
Yeah.
I'm so lost
It
right now.
just looks like
Over and over again.
It is. Okay, it is a lot of ones. How about this? Let me change up some color here. So in between, it's give me these, and then, so in between, so it's just this piece right here, right? And then this where I'm doing all the math over here. This piece, right? Does that make a little color coordinate a little bit?
Yeah, I don't get where all the fractions came from.
Okay. I'll do it again. I'll do it again the other way. So I still got to clean up this. So right here, when I rationalize this, it's going to give me 2 rad 2 over 2 minus 1.
Wait, because you multiplied this.
Yeah, so do I rationalize that, right? So what can I do with those 2's? So my final answer is rad 2 minus 1. Now, for the sake of the video and for the sake of the question, I'm going to do all the steps, but I'm going to do it from the other one up there. Okay, so I'm going to take it from my 1 minus rad 2 over 2 divided by rad 2 over 2, okay? So we had 1 minus rad 2 over 2 divided by all right. Now, see this 1? I don't like that 1. Why do I not like that 1? It's by itself, but I need a common denominator. I want common denominators, don't I? I'm going to do 2 over 2 because this other one already has a 2. So it's going to be 2 over 2 minus rad 2 over 2, and everything is still being divided by rad 2 over 2. Now, I'm going to change colors to go to the next one. Maybe this will help out. Yeah? Okay, so next one's going to be changing colors. So there's a couple things I can do here. So I can multiply everything by the common denominator. What's the common denominator on everything here? 2. And when I do that, it's going to look like this. So I'm going to multiply the top by 2 and the bottom by 2. So when I distribute my 2, what's going to happen if I'm multiplying by 2 and I'm dividing by 2 here? Those cancel, right? And so what's going to be left? Just the 2, which was on top. Minus. When I distribute here, it's going to be this 2. So I'm multiplying by 2 and dividing by this 2. Multiply and divide. Those will cancel. Those will give me 1, right? And so what's going to be left is on top, which is rad 2, right? Now we're doing the same thing on the bottom now. So if I do the same thing on the bottom, what's going to happen? So this 2 and this 2 will cancel. And this helps out a lot, especially when I have complex fractions like this with a bunch of fractions. Multiply everything by the common denominator and it cleans up a lot. So those will cancel. I'm left with just rad 2 there. Okay. Close to the answer. Now I'm going to Pac-Man this one. Waka, 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 waka. Okay. So I'm going to have 2 minus rad 2 over rad 2. Now my step, I'm changing colors again. What do I not like about this? Yeah, radical in the denominator. So I'm going to multiply top and bottom by rad 2 over rad 2. But if you notice, the denominator only has one term. So I don't have to conjugate. I don't have to conjugate. If it was 2 terms, if it was like the top is, the 2 minus rad 2 on the bottom, I would have to multiply by the conjugate. But this one term. That's why we did it in this way, to make it easier. So I'm multiplying top and bottom by rad 2 over rad 2. Now from here, again, I'm going to distribute a rad 2 into the top. So I have a whole number times a radical. I'm going to treat the radical like it's a variable. So that's going to leave me just 2 rad 2. I'm just going to put them together. And this next one's going to become minus, right? Because it's a negative times a positive. What is rad 2 times rad 2? It's just going to be 2, right? Because it's rad 4 and square root of 4 is just 2. So that becomes just 2 right there. And the bottom of my fraction is rad 2 times rad 2, which is going to give me again rad 4, which is just, so the bottom has 2's.
Do those cancel out?
It will, but I can't just cross it out. I have to factor it first. Because the top of them, the top both have a 2, right?
Oh, I see.
I'm going to do blue. So what I'm going to do is, I'm going to take out a 2. So I'm going to factor out a 2. So divide this by 2. So what is 2 rad 2 divided by 2?
Rad 2.
Just rad 2, because the 2's will go away, right? Because I just factored that out. Yes?
Yes.
Does that make sense?
Yes.
Nat? No? Watch. Here, I'll do it off to the side right here to show you. So what I'm doing is 2 rad 2, that's this, and I'm factoring, so it's dividing by 2.
So then those would cancel out?
And you're left with this rad 2. Does that make sense now? Okay, so I'm going to do the same thing on the other side now. I'm going to do the same thing on the other one, right? So it's now going to be this one. So it's negative 2 divided by 2 is going to give me
Wait, oh, divided by.
divided by. So it's going to look like this. It's negative 2 divided by 2, because that's when I factor. This 2 is the bottom 2 here. And this 2 right here is the one on top. So 2 divided by 2? Yeah, just 1. But I got a negative there, so it's negative 1. And I'm closing that in parentheses because I factored it out. And what's left on the bottom? The 2, right? This is the why I factored it first, because you can't just cancel. You can't just cross out from one thing or the other. The mathematical process is take it out first, divide everything first by that, and then do that. So now those will cancel, so you're left with just rad 2 minus 1. Or if you did the Gustavo method, Gustavo right here at this point said, hey, I'm going to take my 2 rad 2 minus 2 and break it up into 2 separate fractions. That's the Gustavo method. It only works out if there is a common factor. If there is a common factor. If there's not a common factor, you just separate it and made more work. Because those cancel still, and those cancel still. Nat, did you see that? You were like zoning out there.
Yeah.
Okay, that's the Gustavo method. He said separate this right
I mean,
there.
I get what he's doing, I don't get where the numbers come from.
Oh, which ones?
The whole thing, like, I understand it step by step and how the numbers come in, but like right there where he just got everything, I don't know where he gets all that.
This one right here? This one right here in orange. Or before that?
No, the bottom two, the thing you just did right now.
Oh,
like,
okay. Here it is right here. See, there's 2 things on top, right? They're over a common denominator. Right? They're common denominator, so we put it under one thing. Just 1, 2. Right? We could separate it again if they are common and just put 2 rad 2, which is this, divided by the denominator, which is 2, minus sign, right?
that two.
Then this 2 goes right here, right? Divided by the common denominator, that 2. Makes a little more sense or no? We'll try. Just go ahead. We'll try some practice here. So for the video, I did them both ways. Now, for you people to understand, this is going to be your I-Day assignment. Example 3 is going to be the I-Day assignment, and you're also going to have to start working on that review for the test review. So, I know Tony is not on his phone, especially while I'm talking about something he's supposed to be doing. So this is going to be important for what we're doing later on. Okay? So, don't forget, like, share, and subscribe, hit that notification button, and buy stuff from my merch store. It provides me new socks.